All right, so let's talk about N-tier architecture. So generally, a tiered architecture would talk about how the application is laid out in terms of what computers, or more realistically, what servers are operating under which group of um, or set of computer tiers, if you will, in the ecosystem for that application or software solution, right? So um, we could typically design an app to have, just a one tier solution, or we could design the application to support, a two tier application where there is a client piece of software that runs on your machine, for example, but then talks to a different server in the back end. So generally, some ERP solutions might have you install a client, some type of software that runs on your machine, but then the database behind the scenes and some of the application logic might be hosted on a server that your computer connects to. So when we have that type of solution, we'll call it a two-tier application. So two tiers: the client tier and the server tier. One tier application would be something like Microsoft Word. It runs on your machine. It doesn't really need to talk to a server on some other corporate, network somewhere. You just create your documents on your local machine and save it on your local machine when you're done, that type of thing. So that would be more of a one tier application. Now, fast forward to when we're building web applications that would be public facing, they'll be accessible by people on the public internet. Generally, the thought is that they we would host this web application on a server, one machine, and then we would have others connect to it using their client machine, which would be kind of a web browser in a web application scenario. So since we're focusing a little bit more on web applications, we would have a presentation tier, which is what would involve kind of um, your client machine, the web browser, that type of thing, right up here. Then that interacts. You see a bi-directional arrow indicating that your client interacts with an application tier or a web server tier or a web tier. Sometimes this could be the website, generally, or a responsive mobile web app, right? Mobile friendly web app, if you will. That's also probably sitting on some web server. That web server information probably could be talking to a business logic tier or web service layer, or some interoperability layer in the middle, or middleman, which facilitates the communication with the database server. So general best practices is when we're building a web app, we typically don't want to host the database server on the same box as the web server. So if you're building a PHP app, you'd have your mobile app talking to a web server. Web server then talks to, um, you know, a MySQL database. And this tier might be optional. But if you need to expose this web app functionality to a different mobile app, let's say an iOS app, then you might create an API in the middle, and the web app would talk to the API. The mobile app would also talk to the API, and the API would be kind of the conduit to talking to the database. So the website and the mobile app generally would not talk to the database directly in this scenario. We'll kind of have a middle tier that allows that to happen. So if we have this kind of segmentation of tiers, this is an example of a four-tier architecture. So tier 1, tier 2, tier 3, tier 4, right? Um, we talked about layers. Here's an example of four-tier architecture. Let's talk a little bit about some more complicated scenarios. So this is perhaps another scenario where we might have, you know, a user interacting with a client presentation layer, which then talks to a business tier. This could be, some type of business logic layer, which then talks to The data access layer, and the data access layer might talk to a database, but we might have an external application that then talks to their own API, and their API talks to our API to be able to store information in our database. Generally, when you're thinking about how things are integrated, you want to start off by thinking which things are going to be talking real time. So if we have a web service that's going to be talking real time meaning if I make an update, it shows up in the database right away, then we would be thinking of using some type of API. API being application programming interface, also typically known as a web service, right? If my thought process is that I'm going to be able to make some updates in some system, and that information will be loaded periodically, or let's say on a nightly basis or on hourly basis, then I'm thinking of a batch process, right? A nightly feed of data from application A to application B. In that case, we'll use something more like an ETL process. So if I'm going to allow people to come to my website, order products, and when I need to ship those products, I need to send that information from my website's database to, let's say, SAP, being my external ERP system. Then I might need to build some type of extract, transform, load process, or a batch program of some sort. And so that's what ETL is extract, transform, load batch process. This would be more for nightly updates. If I'm going to have more of a real-time communication, then I need an API, of some sort. All right, so here's an example of how I might depict a complex application that we might be building in terms of an n-tier software architecture, right? So I would say I have users who are going to be interacting with my website. Now, websites are hosted on web servers, so the raw web pages would be on a web server. And to be able to get to a web server, you would need to use a web client, right? A web browser like Chrome or Firefox, something like that. So my users will interact with the web browser. The web browser is going to talk back and forth with the web server. But I've introduced this internal API web service in the middle because I think my users might also try to use the mobile app to access the same logic that I have. So let's say I'm building an app, e-commerce application that has a way for people to look for how to locate a store, for example. So I have a store location type feature, and I chose to use a Google Maps API. So now I've built an API here where I would have my API called the Google Maps API. And the Google Maps is an external API, so notice it's not part of what I'm building. The stuff that I'm building is in green, right? So I'm going to build this app, this internal API. I'll build a website that talks to this internal API, and then that API would talk to the Google Maps API. And once I build that logic for my internal API to talk to the Google Maps API, I don't have to build the same functionality for my mobile app. And in this case, IVR is kind of an interactive way for people to call in through my call center and talk to an automated voice recognition system, right? So I have 3 different ways in which my customers can interact with this application. They can call in through IVR and talk to my API, which would then communicate with the Google Maps API to figure out, oh, okay, you're trying to get to the store in Appleton. How do you get there? How do you find that? You could probably do that through the IVR, or they could simply open up the mobile app, go to my locations near me type solution, and on my app, and I would be calling the Google Maps API to provide directions on how to get there. Or they could also go to my webpage and look for a store that's close by, and I would call the Google Maps API, figure out the current location of the user, that type of thing, and then provide them with directions. And then I might probably save that information into my database. So this internal API component here, layer or tier, if you will, is kind of serving as the broker between all these things, and I would have all my logic stored here to make it accessible for these different engagement models. You know, users can engage with the mobile app, they can engage with the IVR, they can engage with the website. But to use a website, you kind of need two tiers. You need a web client to talk to the web server, right? And that type of thing. So that's an example of how you might design your architecture. Uh, if I needed to bring in some additional information from an external location, for example, I might, consider maybe saying maybe I have something here that's, maybe I'm sending the information to SAP, um, SAP orders, right? And so I have a box here in my architecture. Um, and I'm going to perhaps build something that's going to fetch the data from my database servers and send it to SAP. So, um, we can, I'm going to draw something here real quick. I'm going to put something in the middle here. I'm going to call this an ETL process or batch app or ETL. And what it would do is it would run on a nightly basis, fetch information from, my database server, and then send it to SAP so we can do the order fulfillment, right? So this is an example of how we could talk to a web service real time. This is some type of batch ETL process that I'm building, so you could send information to some backend system, right? Probably change the colors of these if I wanted to, so on and so forth. But that's the basic idea of how you might design your architecture. It doesn't mean you need these components all the time. If you're building an app that only has a website and no mobile app, you would not necessarily need to implement an API. You can go straight from the web client to the web server to database server. But for security purposes, generally a good idea to separate the web server from the database server. We don't want to, typically the database server is going to be in a trusted network, right? Web server can be in a DMZ if you understand how networking typically works in an enterprise environment. So this would be probably in the less secure area of your network, publicly accessible, but the database server, which is the biggest asset that our company has, would be protected behind the firewall trusted network, right? So anyway, this is an example of how you might craft your N-tier architecture. We'll stop here and talk to you soon. Bye.